All right, take two. So hopefully this time I have my microphone not muted like I had on the first time we did this. Okay, so we have a student who's begun to solve the following system using Gaussian elimination method. So we started out, we have our system equations. Our student has made an augmented matrix. Now for augmented matrix, all we're going to do is we're going to take the coefficients for each of our variables and then our constants, and we're going to copy those down. So -4, 2, -2, -2, good. -5, -5, 5, good. -1, -2, 2, good. 18, 12, 4. So step one is good. Our student is a go at this station. Now we start in on our row operations. We have this R3 minus R2 arrow R3. And all this is saying to us is we're going to take row 3, we're going to subtract or add the inverse, add the negative of our row 2, and we're going to put the result into row 3. So we have row 3, which is -2, 5, 2, 4. And we have row 2, which is -2, -5, -2, 12. And we're going to make that a negative, so we're going to flip all of our signs. And now we can just add it together. -2 plus 2, 0. 5 plus 5, 10. 2 plus 2, 4. 4 plus a -12, -8. And if we look, that's exactly what we have right here. So step 2 is good. Step 3, we're going to take 2 times row 2, subtract or add the negative of row 1, and we're going to put the result into row 2. So 2 times row 2, we have -4, -10, -4, 24, and then we have -4, -5, -1, 18. And we're going to subtract, or we're going to flip our signs. And we end up with -4 plus 4, 0. -10 plus 5, -5. -4 plus 1, -3. And then 24 minus 18, or plus a -18, 6. And if we look at row 2, it's exactly what we have. So our student is on a roll. Good job. So a student made an error? Nope. And so now what would be the appropriate set of row operations for step 4? So remember, with our row operations, what we want to end up with is where this 10 is, right here, we want a 0. So that we have this 0, and another 0 right there. So what we're going to do is we need to get rid of that 10. Can't do anything with row 1 because that -4 in the first position would mess us up. So we got to use row 2. So we need this -5, we need the same value opposite sign. We already have the opposite sign, but we need to multiply this 5 by 2 so that it becomes -10, and we add together and it cancels out. So I'm going to multiply row 2 by 2, so 2R2. I'm going to add that to row 3, and then I'm going to put the result into row 3. Now I don't have to actually do it because it doesn't ask me to. It simply says what would be the appropriate set of row operations. So that's it. We're done. All right, going on to number 2. Model airplane takes off at a constant rate. Let's highlight constant rate here. Constant rate of 11 feet per second. At the same time, a ball is launched at ground level with an initial velocity of 52 feet per second. How long will it take the airplane and the ball to collide? So let's write our two equations. Airplane has a constant rate. Draw our airplane. There's our little airplane. Put a wing on the other side so it doesn't fall out of the sky. Constant rate of 11 feet per second. Linear motion. So height equals 11 t. And we're taking off from the ground, so we're assuming height at time 0 is 0. So there's the equation for our plane. Anytime you see constant rate, think linear motion. Our ball, on the other hand, is thrown into the air from ground level with an initial velocity of 52 feet per second. So when you see something thrown with an initial velocity, think quadratic. It's going to go up, and then gravity is going to take over and pull it back down. So we're going to use our quadratic. H equals A is gravity. So this is either negative 9.8 meters per second squared or negative 32 feet per second squared. In this case, since we're talking feet, it's going to be the negative 32. So half of that, negative 16. We have an initial velocity of 52, so 52t. And again, we're starting at the ground, so we're going to start at a height of 0. So we just leave the 0 off. We have two choices here. And a couple of choices. But we have two easy choices. We have h equals 11t and h equals negative 16t squared plus 52t. We could graph this into y1 and y2 using x for t, and then do second trace intercept. To find our two intercepts, or because both of these are set equal to h, we can substitute this 11t for this h, and we end up with 11t equals negative 16t squared plus 52t. Subtract 11t from both sides. 0 equals negative 16t squared plus 41t. And now we can solve because we can factor here. And we have 0 equals negative 16t. So I'm going to divide out 16t, which leaves me with a t here minus 41 over 16. So this first negative 16t tells us if we ignore the second factor and set negative 16t equals 0, then we have an initial intersection at t equals 0, which makes sense because at time 0, they're both on the ground. And then if we look at our second expression, t minus 41 over 16, set that equal to 0, and we have t equals 41 over 16, or 2.5625 seconds. So either way will work. We can do it algebraically, we can do it graphically, whatever floats your boat. All right, going on to number 3. Following information below, what is the solution for z? So let's look at what we have going on. We're not quite in normal standard form, but we have all of our variables in columns and then our constant on the other side. So we're going to go ahead and leave it as is. So we have this x, z, y configuration. So the 1 here tells us we have 1z, or 1x equals 0, 1z equals negative 2, and 1y equals 2. So z equals negative 2. And that's all there is to these. If we have the solution matrix, the 1 tells us which variable, and then the fourth column tells us what that variable equals. All right, number 4. Be careful with this one. It's not asking us to solve. It's asking us to write a system of equations. So that's all we're going to do. And the nice thing is we have this table. This table is our augmented matrix in disguise. It's like an Autobot. All we need to do to write our systems is create some variables. And the easiest way to do that is we're just going to use the first letter of each of our pizza types. So we have 12 cheese pizzas plus 20 pepperoni pizzas plus 8 sausage pizzas. We have 74. We have 15 cheese plus 31 pepperoni plus 12 sausage equals 108.50. And then we have 9 cheese plus 13 pepperoni plus 5 sausage equals 49.50. And we're done. That's it. Not solving, just writing the system. All right. Pause for a second. And going on to number 5. Number 5, write system of inequalities that describes the solution below. Oh, we need our lines. Remember our format for a line, y equals mx plus b, point slope form, where b is our y-intercept and m is our slope. And slope, remember, is simply rise over run, the change in y over the change in x. So if we take our dashed line one first, and we look, we've got an intercept here at positive 2, and we have a slope that looks like it's going down 1 over 2. So we have negative 1 over 2 for the slope, plus 2 for the y-intercept, and then we've got our y. So we have to figure out which way we're going. So if we come over, and if we put 0, 0 in, if we put a 0 here for y and a 0 for x, we end up with 0 and 2. Less than. Because 0 is less than 2. And it's less than because of the dashed line. Let's try this again with our second one. We have y. We have an intercept at negative 2. And this one, the best point, it looks like we've got this intersection here, and then we've got this y-intercept. So it looks like it comes down 5 over 2. So we have negative 5 over 2x minus 2, because our y-intercept is negative 2. And again, we're going to put in zeros for x and y. And in this case, 0 is greater than or equal to negative 2. So there we go. And there's our two equations. All right. Number 6, order triple for our given system. So first things we need to do, are we in standard order? We have a column of x, we have a column of y, we have a column of z, we have a column of constants. We are good to go. So we're going to write our augmented matrix. So 1, 1, 1, 3, 2, negative 1, 2, 6, 3, 2, negative 1, 13. And we're going to go into the calculator, and we're going to go first to second x to the negative 1, math, reduced row echelon form, with little parentheses. So that gets our reduced row echelon form operation up first, and you should see that up on the screen. And then we're going to go alpha, zoom, to create our 3x4 matrix. So you should then see your reduced row echelon form, parentheses, and then a 3x4 matrix of zeros. You plug in your augmented matrix, you hit enter, and you should get a solution matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, And let's see what numbers I ended up with. 4, 0, -1. So again, x, y, z. So 1x equals 4. 1y equals 0. 1z equals -1. And there's our ordered triple for the given system. And if you really couldn't figure that out, you could test each one of the answers. Plug in the ordered triples into the system of equations and make sure it works. Find the solution that works in all three. But really, this is the easier way. All right, number 7. Swim team is selling t-shirts to raise money. T-shirt price is $10 for students, $15 for everyone else. The team needs to make at least $1,000. So we're going to pause right here because we have an equation. Anytime you see money, and then an at least money or more than money, there's your first, there's an inequality. So we're going to say students is S and everybody else is E. So we have $10 for each student t-shirt plus $15 for everybody else's t-shirts, at least, so greater than 1,000, or greater than or equal to, because at least means 1,000 works. If it said more than 1,000, then it would just be greater than. So there's our one equation. But they only have 100 t-shirts to sell. Therefore, the number of student shirts they sold plus the number of everybody else they sold has to be less than or equal to 100, unless they're a bunch of con artists and they're selling the same t-shirt to more than one person. But we're going to assume they're good kids. And therefore, there's our system of equations. All right, pause for a second. And slide on up. Solve. Y equals -8x minus 16 equals x squared, and y equals x plus 6. Two options again, graphically and algebraically. Again, whichever one works for you. So graphically, you would just solve the first equation for y. So you go y, add 8x and 16 to both sides. So x squared plus 8x plus 16, and y equals x plus 6. Second trace intercept, find your 2 points, or 1 point, or no point, depending on how they work. In this case, you should get 2 solutions. Alternatively, we could substitute in this x plus 6 for this y. We have x plus 6 equals x squared minus plus 8x plus 16. So subtract from both sides, and 0 equals x squared plus 7x plus 10. At this point, you could use a quadratic formula, and you would end up with x equals -5 and x equals -2. And then you would just take these two x's, put them in this linear equation to solve for the y's, and you would end up with -5, 1 and -2, 4, which is what you should get if you do the second trace intercept graphic method. All right, going on. Graph system of inequalities is the ordered pair -3 to a solution to the system. Now I know it says graph, and we will graph it, but you could just as easily plug your points into your inequalities and check to see if they're both true. If they're both true, then yes, it is. If one or both of them are false, then no, it's not. But let's graph. The easiest way to do this, we're going to take our first inequality, and we're going to put a 0 in for y. So we have 4x greater than -6, x greater than -1, 3 halves. So we come over here. So our x-intercept is at -1.5. And then we go back again, we put a 0 in for x, and we have 3y greater than -6, or y greater than -2. And we have right here. Now, greater than, dashed line. And there we go. And we can check, plug in the origin 0, 0. Is 0 greater than -6? Why, yes, it is. So you know what? I'm going to do highlighter. So we're shading that way. Now I'm going to change colors for my other line, my other inequality. I have x minus 3y less than or equal to -9. So first things first, I'm going to put in zeros for y, and I have x less than or equal to -9. So I got to extend my columns because our graph is too small. 6, 7, 8, 9. So we're right here-ish. And then we'll put in a 0 for x and solve for y. So we end up with -3y less than or equal to -9, y less than or equal to 3. So my y-intercept is 3. Here, equal to, solid line. Now I'm going to put zeros in, and it's 0 less than -9. No, it is not. So I'm going to shade away. And we can see our little purple region right here is our feasible region, or our solution region. Whoops. Good Lord, misspelled region. Now, this -3, -2. Let's come over here. -3, -2 is right here. Now we need honestly, we still need to check because my lines are off a little bit. So we check our first one, and we have 4 times -3 plus 3 times 2 greater than -6. So -12 plus 6 greater than -6. -6 greater than -6. Is -6 greater than -6? Negatron. So, false. And therefore, -3, -3, 2 is not in the solution to the system. All right, number 10. Let's erase some of my stuff here so we can see what we're doing. We have Jeremy. Jeremy's out buying pizza and stuff. He buys 2 slices of pizza X, so 2X. He buys a drink. And he spends $5.50. Macy buys 1 slice of pizza plus a drink plus 3 cookies, which are Z. And Macy spends $6.50. And then our last piece, a slice of pizza costs $1 more than a cookie. There's a couple of different ways we could do this one. So we have our slice of pizza, and we're going to say it's equal to a cookie plus $1. Now we can double check this. If my cookie is $3, I add $1 to it and 4. So my slice of pizza is $4. $3 is $1 more than $4, so we're good. There's our system of equations. We're done. If we needed to put this one in standard form, we could just bring the Z over to one side. And that's it. No fuss, no muss. All right, let's go on the next page. Almost done. Kelly has 36 coins in her purse, only nickels, dimes, and quarters. She has 8 more quarters than nickels. Total of $6. How many does she have of each coin? You can see our equations are already written, but we have to fix this one. It's not in standard form. So I got to bring that x over. So negative x plus y equals 8. And now we're ready to build our system. I'm sorry, our augmented matrix. So we have 1, 1, 1, 36, negative 1, 1, 0 for z because we don't have a z, 8, 0.05, 0.1, whoops, be careful, 0.25, 0.16. Now when we do this again, reduce row echelon form, alpha trace to build our matrix, and we get our solution matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, 12, 20, and 4. Oops. So Kelly has 12 nickels, 20 quarters, and 4 dimes to drop on people. And we can double check this because do these 3 add up to 36? Yep. Do our 20 quarters equal our 12 nickels plus 8? Yes. And if we were to substitute these in for the values, we would get $6. Done. All right. What is the solution to the linear quadratic system? We're already solved for y. So we could go the easy route and we can just go y1, y2 second trace intercept. And you would get negative 1.83 comma negative 3.66 and 3.83 comma 7.66 as our 2 solutions. So y1, y2 second trace intercept, don't overthink it. If you wanted to do it algebraically and you went through the quadratic equation or the quadratic formula, fine and dandy. There's nothing wrong with that. All right, 13, solution to the system of inequalities. The nice thing here is we are already in point slope form. So our first inequality, we have a y-intercept at negative 3. And then we have a slope of 4/3. So we're going over 3 up 4. And we're using dashed lines. If we put in 0, 0, is 0, whoops, sorry, is 0 greater than negative 3? Why, yes, it is. So we are shading towards the x-axis right there. And then our second one, we have a intercept at 2. And then we have a slope of negative 1/3. So we're going over 3 down 1. And then we can go back 3 up 2. Again, dashed lines. And you're just going to have to be able to pick which graph looks right. So now we put zeros in. Is 0 greater than negative 2? I mean, sorry, 0 greater than 2? No, it is not. So we're going to shade away from the origin. And again, our happy purple region there, this is our this is our solution. All right, number 14. Ease on down, test. All right, I'm sorry. I've been here way too long. It's almost 6. We have a ball launched into the air from the ground, initial velocity of 71 feet per second. Initial velocity, again, telling us quadratic motion. We're come over here, and we're going to go height. Again, we're doing feet. So we're going to go height equals negative 16t squared plus 71t. We have no initial height, it's from the ground, and that's it for the ball. On my little baseball again. Then we have a balloon that's reached from a height of 60 feet and a rate of 5 feet per second. Rate 5 feet per second screams linear motion. So we're going to go h equals 5t plus, we have this 60 feet at height 0, at time 0 plus 60. Now I can tell you, you could set these equal to each other, use the quadratic formula, but it's probably going to be easier if you go the y1, y2 second trace intercept route. And if you do that, you're going to get 2 intersections, because what's happening is your ball's going up and coming back down while your balloon is going up and keeps going up. So we have this first intersection at t equals 1.35 seconds. And that's the ball passing the balloon on its way up. And then as the ball is coming back down, it's going to cross the balloon's path again at 2.77 seconds. And those are the x values. We don't care about what height they intersect each other. It doesn't ask that question. It just asks for the times. All right. Number 15. What row operation was performed to change our matrix into our other matrix? So if we look, nothing happened to row 1, nothing happened to row 3. Row 2 is where it's at. Really, you only have 2 options. You either, well, you have 3. Did we have any we couldn't have had multiplication going on by itself because we have this 0. We got rid of a number. So we had to have some form of addition with another row. And if we look at this, it's a matter of trial and error. If we tried row 1, we'd have to multiply row 2 by a negative 2. So that would be, and then add those together. So that would be negative 2 row 2 plus row 1 into row 2. And that would look like this. Negative 2, negative 12, negative 4, negative 8, 2, 4, negative 1, 16, 0, negative 8, negative 5, 8. Not what happened. So we did not do this one. Our other option, therefore, is to use row 3. And so we would have to multiply row 3 by negative 1. So we're going to go row 2 minus row 3 into row 2. And that's going to be 1, 6, 2, 4, negative 1, negative 1, 1, negative 7, 0, 5, 3, negative 3. And that's exactly what happened. So R2 minus R3 into row 2 is what worked. Sweet. All right, skip this one. If there's a question on the test that says use substitution, use whatever method works for you. All right, last piece. Let's do some vocab. Easiest way, when you have multiple choice and definitions and words, read the definition, find the word. That way you're not having to read the sentences over and over and over again. So first piece we have the replacement of a term or expression with an equivalent term or expression. That would be substitution, just like you're substituting a player in the ball game. A collection of equations of the same variables which may have as a solution one or more points which satisfy all equations, no solution or infinite solutions. If we look down, this is going to be our system of equations. Horizontal set of numbers on a matrix, horizontal. So C, that's our row. Collection of inequalities of the same variables. Stop right there. That's our system of inequalities. A degree 2 term, expression or equations. Example, xy squared equals 1. That 2 tells us degree 2. So we're going to go E. When we have a degree 2, that's going to be our quadratic. Vertical set of numbers in a matrix. That's going to be our columns. An array of terms, rectangular array of terms, that's going to be our matrix. One or more terms connected by operations, that's going to be our expression. A combination of one or more variables and a constant coefficient, that's going to be an individual term. So an expression might be 2 plus 3 minus x. So you have terms separated by operators, whereas a term itself, 3x squared, all together in one little clump. Highest exponent value of a term, expression, or equation, this is going to be our degree. So that's the exponent, whatever the exponent is. Having the same value, effect, or meaning, equivalent. Okay. A degree 1 term, expression, or equation, such as x plus 1 equals y, should look familiar. It's a line, so a linear. And a set of values which satisfy a system of equations would be our solution. So hopefully if you looked at this, hopefully you've made it through the whole thing and you actually listen to this and follow along, and you should do fine on the test tomorrow. I wish you the best. I'll have some of the formulas up on the board, and we are done.